Welcome to a lesson with Dr. Powell. Let's take a look at some practice problems here on limits. Okay, so again with the instructions on these, all right, I have the problem. You try it out in your own paper, then check for the solution that'll be presented right here. So pause the video now and try it out. Okay, so here's the solution on this one. So at least this is one way of doing it. See this x squared minus 2 right here? I could actually factor that. Actually factor it as x minus root 2, x plus root 2. How in the world did I do that on the bottom? That's because you could think of whenever you have a subtraction of two things, it's always a difference of two squares, no matter what it is. A minus b. This is the same thing as square root of a squared minus square root of b squared, right? I mean, assuming that these two things are positive, that would work, I guess, if you could think of them as a difference of two squares. If we're only thinking about real numbers, at least. All right. So in that particular case, then you could think of this. Then you could factor that as being square root of a minus square root of b, square root of a plus square root of b. Kind of a nice idea. All right. So using that. And erasing what we just had right there. All right, we get this factor on the bottom. Top's x minus square root of 2. Look, cancellation. Hey, what we did is we just rewrote this fraction in such a way that so we rewrite the fraction in an equivalent form that now we can actually plug in square root of 2. So it's kind of a hole filling idea. So this would be equal to 1 over root 2 plus root 2, which is 1 over 2 root 2. And for me, I'm okay just leaving the square root in the denominator. Some people might not like that, but come on, in lots of application problems, especially with trig functions, if you ever come across 1 over square root of 2, that actually is so much nicer to see and work with than square root of 2 over 2. Intuitively, it is. This is like the square root of 1/2 and all kinds of other things, but that's beside the point. Okay, so I'm okay with this solution, is all I'm saying. Okay, that is problem 1. Now, you could have done this in another way. You could have said x minus square root of 2, and then you could have multiplied top and bottom by x plus square root of 2. A lot of people like to do things like that, and that would be okay. But honestly, I think it's a little bit more messy. They think about this conjugate idea. Well, yeah, there's tons of conjugate ideas in mathematics and stuff, but here the multiplication of the top would be x squared. So this combined, if you multiply that out, does give you x squared minus 2, which would cancel out with that, and you'd be left with 1 over x plus root 2, which is the same thing as we had here. Plug in, you're good to go. Okay, that's another way of doing it. That's perfectly acceptable. Like it, great. Okay, so all right, so erase this and let's take a look at practice problem number 2. Okay, so try it out and go for it. Okay, so here's the solution. Basically, just looking for equivalent fractions to the point where domain changes enough so you can plug in a value. So on the top, I can factor the top with a 1 and a 2 plus. That's beautiful. Cancels. You can plug in a negative 2 and a negative 1 now, and you end up getting negative 1 plus 2, which is just simply 1. Okay, so not bad on that. Okay, so that was problem number 2. Now take a look at problem number 3. Go for it. Okay, so here's the solution. How in the world do I work at this? Think of equivalent fractions. So I'm going to multiply top and bottom by the same thing. in such a way that denominators are cleared so I don't have denominators in numerators or stuff like that. So, I mean, think if I multiply top and bottom by x, that's nice because it like multiplies through to everything, and in the process, you get a nice cancellation there. So this would be the same as the limit of, and then you have 2 minus 2x all over x minus 1. You can factor out a negative 2 on the top. I'm going to do that because I want to see an x minus 1 on the top. And I can notice that's what's going to get me an x minus 1 on the top. You can check it out. I mean, you can always work backwards to verify what you did. Negative 2 distributes the x, negative 2x. Negative 2 distributes negative 1, positive 2. Yeah, that was the acceptable way of factoring out negative 2. Notice now you get a nice cancellation. Ha! You can plug in 1 into this. I mean, plug in 1 into a constant. Just get the constant out. Negative 2. There is the solution there for that one. Okay. Thanks for watching.